This video is going to cover the second day of Section 5.8, calculating the area between two curves. Let's recap what you guys learned yesterday. If I asked you to find the area between two curves, such as y equals x plus 3 and y equals x squared minus 3, the first thing you might want to do is sketch the two functions. And when you do that, you have a linear function and a quadratic. And so we are going to calculate the area that is in between these two curves. And so in order to do that, we need to find the limits of integration, so find the low x value and the high x value of where they intersect for our limits of integration. So set the two equations equal to one another, and you get x plus 3 equals x squared minus 3. Get everything over to one side, factor it, and you get x equals negative 2 and 3. So when we set up the integral, our integrand is going to go from negative 2 to 3. And our greater function is the line, and the lesser function is the quadratic because of the larger y values. So then I'm going to distribute that negative sign, simplify, combine like terms. And when I do that, I'm going to get the integral from negative 2 to 3 of negative x squared plus x plus 6 dx. When I do the antiderivative, I get negative 1/3 x cubed plus 1/2 x squared plus 6x plus c, and evaluate that from negative 2 to 3, and you'd get 125 over 6, or approximately 20.833. So today what we're going to learn is what if I give you the two functions y equals x minus 1 and x equals y squared minus 5. Now technically the second one is not a function, it is a sleeping parabola, because you'll notice that this is an x equals equation, it's in terms of y. And so if I were to get y by itself, when I take the square root, I would have to do both the positive square root and the negative square root. And so when I graph this, I'm going to get a linear function and a sleeping parabola. Now what we've been doing with finding area under the curve is that our rectangles have always been vertical, and we call those vertical slices. If I were to create a vertical slice just on this left side here of the sleeping parabola, what's going to happen is that the area above the curve and the area below the curve, the area above the x-axis and the area below the x-axis are going to cancel one another out. Because we aren't changing functions if we were to set up our integral. So we'd be going from y squared minus 5 to y squared minus 5, and that area would cancel out. So what we're going to do today is, instead of using a vertical rectangular slice, I am going to create a horizontal rectangular slice. And so now I can still calculate the area between the curve, but a couple of things are going to be different. So since we're going to use a horizontal rectangular slice, we are going to have to change our two equations. Both of them are going to have to be in terms of y, meaning they have to be an x equals equation. And then you'll notice the greater function is now the function that's going to be on the right side. And then our limits of integration are going to be where they intersect, but the limits of integration are going to be the y values of the intersection. So let's just write these down. So the steps for using horizontal slices to calculate area. So the first thing is that you want to make sure both equations are in terms of y, meaning your equations are x equals equations. The second thing is to find the limits of integration by setting the equations equal, but now the limits are going to be the y values of the intersection points, not the x values. And then the third step is to set up and solve the integral with the greater function minus the lesser function. But now the greater function is the one that's on the right instead of the one that's up above, because this is where greater x values occur. So in solving for this, my horizontal rectangular slice, I have to rearrange the first linear function. It was a y equals, so just get x by itself now, add 1 to both sides, so now I get x equals y plus 1. My sleeping parabola is going to stay as x equals y squared minus 5. And so I'm going to set those equal to one another, get everything over to one side. When I solve for my y values, I get negative 2 to 3. So now my limits of integration go from negative 2 to 3, And my greater function is the line, because that's the one that's on the right. So y plus 1 minus my lesser function is the sleeping parabola. Then I'm going to combine like terms. And when I evaluate this, you guys would find the antiderivative by hand. You would get approximately 20.833. So it is the same area of the volume. It is the same value of the area that we found in a previous problem, but now we just have a line in a linear, or sorry, in a sleeping parabola. So just to compare, calculating area between two curves, you want to use vertical slices when your rectangles can go from curve to curve, so from two different functions. So my example here is an upside down parabola, and then I also have a cubic function, so this would be an example of where we would use vertical slices. A place where we would use horizontal slices is when, if you were to draw a vertical rectangle in any place, if it goes from the same function, top and bottom, then you don't want to use vertical slices. It's easier to use horizontal. And so here's just a comparison. Vertical slices are always y equals equations. If we're using horizontal slices, we're going to use x equals. The limits of integration for vertical slices are always the x values, and the limits of integration for when we use horizontal rectangular slices are always going to be the y values. So the assignment for today is on page 240, and it's numbers 15, 16, 21, 25, 26, 28, and 32. Tomorrow will be a review day, and I will be able to answer any of your questions from your assignments. So if there is time left today, you guys can work on your 2 assignments from section 5.8. Have a good day.